Hello, thanks for joining. We're going to be doing Notes 1.2b, functions. So the first thing that we're going to be talking about is the domain. The domain of a function is the set of possible values of independent variable, and that would be our x. In plain English, the definition means that the domain is the set of all possible x values which will make the function work and will output real y values. So basically anything that we can plug in for x into our function. So these are the main three domain restrictions that you see. Normally a domain of a line would just be all real numbers. So this like fancy R with the two brackets means all real numbers if you're not familiar with that notation. And why that would be is normally like a line continues in both directions, so it's going to stretch across all of those x values and it's going to hit all of the real numbers for x. So the only times that we get into domain restrictions is if, for example, we have a variable in the denominator. Unfortunately, we can't divide something into nothing, so the denominator cannot be 0. We can't equal 0 in the denominator. We can't take something and disintegrate it, at least yet. Okay, variable and a radicand of an even index. So if we have an even number here, we cannot have a negative value under a radical. It has to be greater than 0. It could equal 0, but it can't be less than 0. Because if we have a negative number down here, you can't divide that into a perfect square. We can't take the square root of -4. There's no two numbers that are the same that can multiply to give -4. If this was an odd index, like a 3, say like -8, that could work. Because -2 times -2 times -2 does give us -8. But if this is even, you can never split something into an even amount of things and get a negative number. All right, finally, logarithm. Our domain restriction for a logarithm is that it also has to be, and in this case it could equal 0 because we could have the square root of 0. I said that, but I didn't write it, sorry guys. For this one, it has to be greater than 0. Because remember, logarithm is like an exponential power. We can write log, so log base a of x to the equals b. If we rewrote this as an exponential, it would be like this. There's no way that you can come out with a negative, because if you put in a negative exponent, all that does is it just makes it a fraction. So there's no way that one is going to be negative. It's greater than 0 for your x. Okay, so those are your main restrictions. Otherwise, it should pretty much be all real numbers or the set of x values that are there. So here, the domain of each function. This one wants the set of x values. What are our x values here? All of these. So our domain is, we fancy bracket it, -3, -1, 0, 2, and 4. For that function, it's only those values of x. What about this one? This is an actual function. We could plug anything in for x. Do we have any of these restrictions? Do we have a variable in the denominator? No. Do we have a radicand with an even index? No. Do we have a logarithm? No. So this one is all real numbers since there's no other restrictions there. Next, we have a function. Okay, let's check through. Do we have a variable in the denominator? Yes. The denominator has to not equal 0. So for this one, we need to figure out, where does x plus 5 equal 0? Because it can't. It can't equal 0 down there. So we solve. X cannot equal -5. So this one would be everything except for -5. So it'd be all real numbers except for -5. Sometimes you'll also see it written as from -infinity to -5, open bracket, -5 to infinity. So the way that this works, I shouldn't have closed that bracket, sorry. From -infinity to -5, it's saying we can take everything below -5 all the way up to -5, and then we're going to skip right over it and go all the way up to infinity. Okay, next. Find the domain of each function. So these ones are a little bit different. In this case, do we have a variable in the denominator? No. Do we have an even index? No. Do we have a logarithm? No. But this one does say that it's a volume of a sphere. Can we have a negative volume? No, we can't have a negative distance. So for this one, the domain would be all real numbers, but we can't set our radius less than 0. Our radius has to be greater than 0 because it's a volume, because it's a distance. We can't have a negative distance. But otherwise, if this wasn't a distance, it could just be all real numbers. Okay, next. Function. Do we have a variable in a denominator? No. Do we have a radicand with an even index? Yes, we do. So everything under here has to be greater than or equal to 0. So we can go through and solve. Negative 3x is greater than or equal to negative 4. And we divide. X is going to be greater than or equal to 4/3. And that would be all real numbers, but it has to be greater than or equal to 4/3. Hopefully you were able to catch that error. Hopefully as we're watching these videos, we're listening really carefully. I was checking to see if you remembered this. When we divide by a negative, what happens to our sign? It flips. Kudos to you if you caught that. Good job. Okay, next. Going to using a graphing utility to find the domain and the range of the function. So when we get our graphing utility, we hit y equals. And in here, we're going to type square root. So second square root, it's right above that squared button. 9 minus x squared. And we can hit graph. So as you can see on the graph here, for our domain, we're definitely restricted. We have some smaller values. So let's go to trace and see where this domain is ending. So remember, domain is x. So as you can see here, it's going to negative 2.95. And then as we get down to that negative 3.18, we're gone. Let's go to a table and see if we can see this closer. So you do that by going second table. And you can actually see, let's see where x is at 0. It's actually at 3. When x is 0, y is at 3. But what about when y, like we thought that we might get to, we cross it at 3 and at 0. So like it looks like on the graph, it's going like this. And we know this because this is half of our circle formula. So if we go back to the graph, and we can go back to trace if you want, it's there at negative 3 and over here at 3, and then it's up here at 3. So our domain is going to be all of our x values. So we are going from negative 3 to 3. That's all of our x values. It's included because there are points there. So we have the solid bracket. And our range is going to be from 0, it's starting at 0, and it's going up to 3 along the y-axis. Those are also closed brackets there. So we should be able to see that there. Absolute value functions can also be written as a piecewise function. You can see here, we should be able to recall this. I don't know why it didn't type there. X is the same thing, or the absolute value of x is the function x such that x is greater than or equal to 0, and negative x where x is less than 0. So as you can see on this function, what we're doing is this would have been a line, but the absolute value takes the negative values and it flips it up and it makes them positive. So our absolute value function, just to know a little bit more about it, our domain is from negative infinity to infinity, all real numbers, because it's never stopping. It's going to keep opening up in the x direction. Our range, however, though, the lowest that we go on this basic absolute value function is 0. We're going from 0 to infinity, or you could write it x is greater than or equal to 0. Our intercept here is 0, 0, and it's decreasing on everything from negative infinity to 0. It's going down here. It's increasing on everything from 0 to infinity. Okay, so our piecewise functions, these are functions that are split into two pieces as well, just like our absolute value function. This one, it's wanting us to evaluate the function when x is negative 1, 0, and 1. So it's asking us to find f of negative 1, f of 0, and f of 1. So we just need to know where to plug these in. Negative 1, does that fall under greater than or equal to 0 or less than? We're looking at our domain restriction. It's less than 0, so we plug it in on that first one. Negative 1 squared plus 1. So 1 squared, negative 1 squared is 1 plus 1 is 2. F of 0, which one do we go? Less than 0 or greater than or equal to? It is 0, so it has to equal 0. So greater than or equal to 0. 0 minus 1 is negative 1. We're plugging it into the function that matches it. 1, That's greater than or equal to 0, so we plug it in there. 1 minus 1 is 0. Okay, radical. Pretty radical, right? Radical functions, and radical is just another word for square root or roots. Radical functions arise from the use of rational exponents. The most common radical function is the parent square root function given by square root of x. That's also the same thing as x to the power of 1/2 because those mean the same things. As you can see, it starts here at 0 and it's going sideways. The domain is going to be from 0 to infinity because it starts there on x and it's going this way. The range is going to be from 0 to infinity as well because we're going up and down. We're starting at 0, going up to infinity. Our intercept is 0, 0. It's right here. And we are increasing on 0 to infinity. We don't have any decreases because there's no places that function is decreasing. Okay, 2 more problems, guys. We're almost there. Some application ones. So this one says the number n in thousands of employees in the interior design service industry in the United States decreased in a linear pattern from 2007 through 2010. So we have this function here. In 2011, the number rose and increased through 2012 in a different linear pattern. These are the 2 patterns. It wants us to approximate the number of employees for the years 2007 and 2011. So remember, for 2007, that means where t equals 7. For 2011, that's where t equals 11. So all this is asking us to do is to just figure out what is n of 7 and what is n of 11. It's a lot of words, a lot of vocabulary, but all it's asking us to do is to just plug those in. To find n of 7, we have to use this function because 7 is less than or equal to t. That's where it equals 7. So we just use the equation that goes with that domain, and we plug in 7. We could use our calculator for this. Second quit to get out of our graph. Negative 4.64 parentheses 7 plus, what do we have here? 76.2 gives us 43.72 thousand employees because it says it was in thousands. So don't forget your units because that's quite important. And then n of 11, which function are we going to use? Or which piece of the function? The top or the bottom? It's all one function. The bottom, because it's 11 is less than or equal to. So we're plugging 0.90 times 11 plus 20. 0.90 times 11 plus 20 gives us 29.9 thousand people or employees. So make sure to always read the math problems because that one, it was super easy, but it sounded super confusing. So don't miss points just because you didn't read the question because it looked too hard. Okay, a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second. This one feels like one that we want to tune out on, but let's not. Let's bear through it. At an angle of 45 degrees. The path of the baseball is given by this function, negative 0.0032x squared plus x plus 3. And f of x is the height of a baseball in feet, and x is the horizontal distance from home plate in feet. Will the baseball ever clear a 10-foot fence located 300 feet from home plate? Oh my gosh, I just want to give up on this question, but let's not. Let's persevere. We got this. The height of a baseball in the function is the horizontal distance from home plate. So what we need to look at is, let's look at our key information. A baseball is hit at a point 3 feet above the ground, velocity of 100 feet per second. This stuff kind of matters, but they gave us the equation here. That is what explaining the equation. It's 3 feet above the ground, and it's following this path. So it's saying x is the horizontal distance from home plate. So it's saying, will it ever clear a 10-foot fence located 350 feet from home, or 300 feet from home plate? So it tells us x is the distance from home plate. 300 feet from home plate, that's telling us x is 300. Horizontal distance from home plate and 300 feet from home plate. It gave us what x is. So literally, all that this is asking us to do is to just plug this in and see how high it is, because this is telling us the height of the baseball. So it's saying at 300 feet, will it be 10 feet or higher? Let's check. All we have to do for this question is to plug in 300. This problem sounds like it sucks, but literally we're just plugging in 300. to figure out the height of the baseball. So you can do this. Believe in it. Believe in the power of math. 15. So this is saying it would be 15 feet. So would it clear the 10-foot fence if it's going 15 feet high? Absolutely. We got 5 feet to spare. Woohoo!